Look what I did. I got 1,400 miles on ham radio from Washington to Alaska. But that's no big deal, right? Wait, 435 megahertz? How is that possible? Tropo? Not in the Pacific Northwest, but it is possible by satellite. I'm Sid, AB9BH, and I want to tell you about making satellite contacts with FT4. Have you ever thought about working satellites? Does it sound complex and expensive? That's what I used to think. But if you have a moderate-sized VHF station for terrestrial contacts, you might already be most of the way to making your first satellite contact. If you can make it to the end of this video without falling asleep due to my soothing monotone voice, I'll show you working a satellite with my terrestrial VHF station. But first, let me tell you how to do it. So I'm new to satellites and I don't have all the right equipment, but that's just part of ham radio, making do with what you have, making contacts anyway. I just started working satellites and I was surprised that it was a lot easier than I'd expected. Now I'm going to be covering the principles of satellite operation. This is not going to be a paint by numbers exhaustive tutorial. I'm not going to teach you how to use WSJT-X. I assume you know how to use FT8 and FT4. Satellites are more complicated, but they're not necessarily way more complicated. There's more to keep track of, but it's maybe not as much as you might think. Now this is only how I do it. You could set up your station differently. And also note that I'm not going to be covering FM satellites or phone and CW. This is just about digital. So why would you use satellites? What are the advantages of working satellites? Well, first of all, they almost always use VHF, UHF frequencies that are open to all amateur license classes. Anybody with a ham radio license can use these things. The stations doing digital are also using FT4, so the contacts are very fast. If there are no repeated messages, an FT4 contact is 37.5 seconds. That's pretty fast. Satellites are line of sight. There's no endless waiting for sporadic E or HF propagation that a lot of us are probably familiar with, especially in the Pacific Northwest. When the satellite's going to come is predictable. You just need software to tell you. You can earn awards like Worked All States or VUCC, which will impress your friends. It'll increase your score at ham radio. And satellites are a fun alternative when there's something else you want to do, but that's not working. You can pull up the satellite passes and see what's coming soon. So how do satellites work? Satellites are basically repeaters, but they're dual band, generally 2 meters and 432. The uplink is on one band, the downlink is on the other band. Some are single sideband linear transponders. I'll say what that means. Others are FM, meaning they operate on a single frequency pair, similar to an FM repeater. I'm not going to say more about FM satellites, though. We're talking about linear transponders. What those do is they repeat an entire passband. This could be anywhere from 20 to 100 kilohertz. It depends on the satellite. They repeat from the uplink band to the downlink band. Now, most of them are inverting. That means that the output signal is flipped. So if you put lower sideband in, you get upper sideband out. And similarly, the frequencies are inverted too. So if you're at the bottom of the downlink passband, then you're actually transmitting at the top of the uplink passband. Satellites are affected by Doppler shift. This is very important on linear transponders. Doppler shift changes the frequencies observed by you and is not constant. It changes all the time. And finally, to work a satellite, you have to know when the satellite's passing over you and where it is, so you can point your antenna at it. So which satellites should you use for digital contacts? This is one of the more difficult things to figure out, and I can only figure it out by asking other people. As of July 2026, I'm monitoring AO7, AO73, FO29, JO97, and RS44. These last three are the main ones. The first two are a little finicky and not necessarily what you should use for your first time. For FT4 activity, tune about 2 kilohertz above the bottom of the downlink. And as a first test, if you're thinking about trying this out, just try to receive audio of anything at all. Most satellites have a CW, either beacon or telemetry transmission just outside of the passband. Just try receiving anything from there, even if it's drifting significantly. Here in the bottom right, this slanty little parallelogram, I believe, is FT4 audio off of a satellite. Now, of course, it didn't decode because it's drifting so badly, but that gave me an indication that I was on the right track and that this might actually work. Now, satellites can be inaccurate. These things are not precision instruments that are tuned to GPS and have an error of 1 hertz. It may require multiple kilohertz of RIT to adjust to the frequencies that the transponder is actually hitting. So on a new satellite, you should find your own signal first, figure out where it is, and then try to make contacts. Let's talk about software for satellite operation. Now, you're going to need additional software to be able to do this at all. You're going to need path prediction and what direction is the satellite in. That's pretty obvious, right? But also you need Doppler correction. Now, Doppler shift, I think hopefully everybody knows what Doppler shift is, but Doppler shift can change during a pass by up to 60 hertz per second. That's a lot. And so computer control of the frequency that you're transmitting and receiving on is 100% mandatory. Maybe you could get away without this for single sideband or CW, but it's not an option for digital. This is 100% mandatory. Now, there's software out there that will do this. I didn't like the user interface or the price of what was available, so since I'm a software engineer and I've already written a lot of custom software to increase the efficiency of my station, I wrote my own. Finding what software is going to work for you in your station, what you like best, is left as an exercise for the viewer. So what hardware do you need to work a satellite? Well, first of all, you need a dual band radio or 2 radios. That should be pretty obvious. You want to be able to run full duplex, meaning simultaneous receive and transmit, so you can hear your own transmissions. If you have an Icom 9700, that does what you need. Obviously, you need antennas for 2 meters and 432. Now, the ideal for working a satellite is either cross-polarized or circularly polarized. I don't have those. I had regular, plain old linear polarization, so that's what I used. That's what I already had. If you're getting into this from scratch, maybe consider egg beaters. They're omnidirectional. You don't need to rotate them. They send a lot of their signal up toward the sky rather than toward the horizon. If you have directional antennas, you need a rotator, of course. The ideal thing to have is can control both azimuth and elevation. I don't have that, so I have azimuth only. But this is the key. A 9700 plus regular linear antennas for 2 meters and 432 plus an azimuth only rotator is not an exotic station. This is a pretty modest terrestrial VHF station, and so if you already have this, you're about 90% of the way to making a satellite contact. So a little bit about how I set up my Icom 9700, and then I'll show it to you. The Icom 9700 has a satellite mode. This does several special things. I am not using it. I don't like how it works. I think it's confusing. I don't think it's designed very well. I just use the regular radio in regular mode. I use the main band for transmit because it's the only one that can transmit, and the subband for receiving. Now in the back of it there's a physical USB port, one physical USB port. That's actually 2 virtual serial ports, but they're not the same. They're not equal in what they can do. Cat control is only possible on the first port. Now, what my control software does is it computes Doppler shift, it updates the radio frequencies at 10 times per second via cat control on that first serial port, and then the second serial port is used by WSJT-X for keying the radio only. Now, let me show you what my configuration looks like in WSJT-X and on the radio. Okay, so here's WSJT-X. Let me show you how I set it up for satellite operation. The first thing to look at is this configurations menu. And you may not have ever used this before, but you can set up, in addition to being able to set up multiple rigs at the same time, you can also, within a single rig, set up multiple configurations, and that's what I've done here. So my default configuration is for working regular terrestrial contacts, and then I have a satellite configuration with the settings specific to that. Another thing to notice in the menu, in the decode menu, there's a full duplex mode option. You'll want to enable that so that you'll be able to decode your own transmissions that you receive from the satellite. Now let me bring up the configuration window here, and I'll bring up the radio tab. So the first thing to note here is that rig is set to none. That means that I have no cat control at all. That's completely disabled. The software WSJT-X is not controlling the frequency that the radio is on. That's being controlled by other software. And then over here on PTT method, I've selected DTR. Now there's a second option here, RTS. You can select either DTR or RTS. Either one will be fine, but it needs to match what you've set in the radio, which I'll show you in a minute. Now coming down further, you see how the split controls are disabled the way that I have this set up. So remember that with no cat control, the software is not going to adjust the frequency on your radio for where you are in the passband. So watch where you are in the passband. Don't transmit on the edges, because that runs the risk of either decreasing your power or causing harmonics. Now switching to the audio tab, you may not have ever noticed these channel selections on the right, but the Icom 9700 actually sends the main and subbands to different audio channels. So I'm setting the uplink on the main band, and that's going to be the left audio channel. Similarly, the downlink is on the subband, and that is the right audio channel. So I have each of those channels going to either input or output as appropriate. There's only one setting that's really important for how I'm using the radio. Now if you go into the menu and set and connectors and USB send keying and USB send. Now there's off, and there are 4 other settings spread across 2 pages, of course. But the USB-A ones are that first virtual serial port on the USB port. Now I'm using that for cat control, so I don't want to select either of those. Instead, I want one of the other 2, the USB-B ones. That's the second virtual serial port. Now it doesn't matter which one I select. I could select USB-B DTR, or I could select USB-B RTS. It doesn't matter. Those are 2 different signals on the serial port. I can select either one I want, but it needs to match what was set in WSJT-X in the radio configuration. Okay, now that I've covered the hardware and software setup, let me show you the custom software that I use for satellite tracking and operating. You'll be using other software, of course, but the point is to show you the kind of information you'll need to be successful at making satellite contacts. This is one part of my software that is sort of my radio station control center. Here's the area we're focusing on. This area is my satellite tracker. There's a lot of information here, and even though this is a text interface, many parts of this area are actually clickable buttons. Here is the satellite currently being tracked. I can click on it to bring up a satellite selector. This shows me all the satellites I'm interested in and the next 12 hours of their passes. How long until the pass, how long it is, maximum elevation, and the starting and ending headings. I can click View to bring up a visualization of each pass to see whom I might be able to contact. Okay, coming back to the tracker, it displays the downlink passband, that this satellite's transponder is inverted. Then I have controls for tuning. I can adjust tuning, which means tuning on both bands, both the uplink and the downlink, by a kilohertz or 100 hertz at a time. The D buttons let me deliberately add drift to my signal to counteract drift in a satellite. Here are the downlink and uplink frequencies I'm currently trying to hit. These are frequencies at the satellite, not corrected for Doppler shift. As we move to the right, there are various adjustments. Here's the current Doppler shift on each band. You can see that it changes continuously. Next, I have controls for RIT and XIT. The radios and satellites are often off by a little bit. This satellite is usually off by about 800 hertz, so I've pre-configured that value, but I may adjust it at the beginning of a pass. Here are the frequencies, omitting the megahertz that the software is sending to the radio after all of those adjustments. Here's the current azimuth and elevation, start of the next pass, and how long the pass will be. At the bottom of the tracker, there's a connect button to take control of the radio, a button to tune to the beacon frequency, mode buttons. Here I can make adjustments to RIT and XIT. Here are power up and down buttons. Let's talk about power briefly. In amateur radio, the rules say to use the minimum power needed to make a contact. But with a brief contact in the digital mode, we may not ever actually turn the power down from our maximum. With satellites, it's important to dial the power back. Firstly, it doesn't take a lot. 10 watts may be plenty. Secondly, the satellite has a single power budget that covers all the signals in its passband. If multiple signals are simultaneously transmitted in the passband, the power is divided between them according to the strength of each signal. The power is a shared resource, so don't hog more of it than you need to. If your signal is really strong, be considerate and turn the power down. Let's get on the radio. We're at 8 degrees elevation. I'll start by clicking Tune. Hear that tone? See that line at about 1350? That's my tone coming back from the satellite. Pretty cool. I'll click Tune again to stop it. And it stopped. So I know that signal was me. Now I want my transmission to be close to where the program says it is, so I'm going to adjust RIT. I'll hit Tune again, and I'll adjust RIT by a few hundred hertz. There we go. Now the tone is in the middle of the red indicator. It really should be on the left edge, so it's not exact, but it's close enough. Okay, now that I've found my own signal, I'm ready to call CQ. Any second now. That's my signal in the waterfall, and look at this. Have you ever seen yourself in the left-hand pane before? That's me receiving my own signal in full duplex. Now I want to show you how important automatic Doppler correction is. I'm going to turn it off for a couple of cycles to show you what happens. Whoa, see how slanted that is? See how much it drifted in 7 seconds? Now let's see one more sequence. We're transmitting again, and listen to how much lower it is and look how far off we are now. These transmissions are never going to decode. Now I'll turn Doppler correction back on again. And now it's all better. Here's a clip from a satellite pass. The station came up from Alaska, which was going to be a new state for me. Of course, he worked a few other stations nearby me before he got around to me, but he just responded. And that's in the log, a new state for me on satellite. Now I'll skip through a couple of minutes where nothing really happens, but then I received a second station in Alaska. You'll notice that I'm not receiving my own transmissions here. That happens sometimes, but clearly I'm getting out anyway. And that one's in the log too. Speaking of logging, for me, logging a contact is pretty reflexive and I don't really even look at the window, but you need to slow down a little bit when logging a satellite contact. The band that you log should be the uplink, the band you transmitted on. Propagation should be set to satellite, and then select the satellite you used for the contact. Then, you're ready to log it. Here's one of my contacts from earlier, confirmed on Logbook of the World. Logbook of the World has extra fields for satellite contacts. Not all of them are necessary, but some of them are. Here are some usual fields. Band is required, and as I said, band must be the uplink band. You can upload receive band and receive frequency if you want, but they're not required. Importantly, propagation must be set to satellite, and the satellite must be set to the satellite used. Logbook of the World requires that these fields match what the other station submits in order to get a confirmation for a satellite contact. That's it. Think about trying to make some satellite contacts with your terrestrial station. You might be surprised at how successful you can be. 73, and thanks for watching.